All right, next we'll be solving systems of inequalities. So if you recall, inequalities are where you have dotted and solid lines and where you have to do some shading. And we will fill out this part, which is the solution of a system of inequalities. We'll fill out that part in a little bit. But first I want to go through and actually solve it by graphing. So you can see the graph first, and then we'll talk about, once you have that, where the solutions are. So for the first example, we have one inequality that's written in that standard form. So we have to get the y all by itself. So I'm going to go ahead and off to the side, I'm just going to write it, and I'm going to write it with an equal sign because for me that feels a little bit easier to solve. So I want the y all by itself. I want this to look like the previous problems that we talked about before, where when we graphed them we had y equals mx plus b. Those are a little bit easier to deal with graphing, so kind of like this one. And so I want the y alone, and that means I'm going to be taking the 5x, and since it's positive I'm going to subtract it over to the other side. And so I have a positive y equals a negative 5x and a positive 2. And here, since the y, here, since the y does not have a coefficient, it doesn't have a number in front of it, I don't need to divide anything. The y is actually already alone. So I've got negative 5, which is a whole number. I'm going to make it a fraction by placing a 1 underneath, so I can think of rise over run. So I'm starting at a y-intercept of 2, and then from there I'm going to go down 5, right 1, down 5, right 1. So 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And I ran out of space this way, so I'm going to do the opposite pattern in the other direction. So up 1, 2, 3, 4, 5 to the left 1. So now, to figure out how to graph this, I'm going to go back to the original inequality, and it has a less than symbol, and it does not have an equal to, and so that means that this should be a dotted line, not a solid line. So I'm going to go ahead and make this dotted. And then from there, I have to figure out how to shade this. So with my shading, I just need to pick a point on either side of the line. And I like to pick points that are over here because the x and the y coordinate are positive, so they're easy to plug in. It doesn't matter which point I choose, so I'm going to choose the point 4, 1 right here. So that's 4 for the x coordinate, 1 for the y coordinate. And then I'm going to plug it into the inequality. So I have 5 times x plus y is less than 2. 5 times 4 is 20. 20 plus 1 is less than 2. 21 is less than 2. So now I have to ask myself, is it true that 21 is less than 2? No, that is false. So that means that this number right here, that point is false, which means that the other side is true. And so I'm going to be shading over here on the other side. Okay, so I'm done with that line. Now to do the other line, I'm going to go ahead and grab a different color. For me, I'm just grabbing markers. And I'm going to be really careful when I graph this one, since markers do not erase. So for the next one, I have a y-intercept of negative 5 and a slope of 2. I'm going to make that a fraction by putting it over 1. So I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and then in the opposite direction, down 2 to the left 1. Now with this inequality, it says greater than or equal to, so that means that this is a solid line. So I'm going to go ahead and connect these dots with a solid line, okay? And so now I'm going to go ahead and pick a point on either side of the line, and just a point that would be easy for me to plug in. I'm going to go ahead and pick the point right here. This is the point 1, 3. So 1 for x, 3 for y. So I have 3 is greater than or equal to 2 times 1 minus 5. 3 is greater than or equal to 2 minus 5. 3 is greater than or equal to negative 3. So I'm going to ask myself, is it true that a positive 3 is greater than a negative 3? And that is true. So that means if I'm just thinking about just the blue line, on the left side of the blue line I have my point, the point is true. On the right side of the blue line I have all the other points, all those points would then be false. And so I'm going to go ahead and shade over here on this side. Okay, so now we can kind of go back and talk about what solutions are to a system of inequalities. So the solution for one inequality would be the shaded part and then any point on a solid line. So for the blue inequality, all this shading are solutions, and then all the points on the line are solutions. For the pencil, all the shading is part of the solution and the dotted line is not. So if I take both of these and put them together, then the part that is the solution is the part that is pencil and blue, as well as this part of the blue line, but not this part, because this is not part of the overlap. So this part of the blue line, not where they intersect, because it's a solid blue line and a dotted pencil line intersecting, so anything that's dotted does not count. So where they are double shaded right here, all of this would be considered a solution. So a solution to a system of inequalities is where the shading of two or more inequalities intersects, as well as solid lines around the double shading. I hope that makes sense. This definition, let me make sure it all fits in the screen there. This definition is more me putting it into my own words rather than having a formal mathematical definition. So it's where the shading of two or more inequalities intersect. So right here, think of it as like the double shaded area, the blue and the pencil. So this part right here. And then the solid lines, not the dotted lines. Dotted lines are not answers. And when we practice this in class, we'll be practicing that. So I'll be asking you, I'll give you a point on a dotted line and say, hey, is that part of the answer? And you'll say, no, that's not part of the answer. Okay, let's try the next example. So the next one starts with a y-intercept of 6. And we go up 1 to the right 2. So up 1 to the right 2. Up 1 to the right 2. I ran out of space that way, so I'm going to go the opposite. Down 1 to the left 2. 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 The symbol tells us to draw a dotted line. Okay, and now I have to pick a point to plug in and see if that point is true. So I'm just going to pick a point over here. I'll do the point 6, 2. Okay, so 6 is the x-coordinate, 2 is the y-coordinate. So I've got y is less than 1/2 multiplied by x plus 6. So 1/2 times x is 1/2 of 6, which is 3. 2 is less than 9. That is a true statement. So this is true. The point is true, which means the other side of the line is false. Okay, so I'm going to shade all of this. All right, now for my next line, I have x is less than or equal to 5. And so whenever I have a single variable like that, it just means that the x coordinate of every single point on that line is a coordinate of 5. So I have the point 5, 0, 5, 2, 5, 4, 5, 8, 5, -3, 5, -6, all of those points. So it makes a vertical line. And now it's got an equal to, which means we have a solid line connecting those dots. And now I'm going to go ahead and pick a point to plug in. I'll go ahead and use the point 2, 4. Okay, 2, 4. 2 for x, 4 for y. And here, I only have a place to plug in x. I do not have a place to plug in y. And so I'm only going to plug in the x value. So it says x is less than 5, so 2 is less than or equal to 5. Is that true or false? That is true. So the point is true. That means the other side of the line is false. And so I'm going to shade this direction. So I can already see my double shade is right in here. So the blue line is part of the solutions. This dotted pencil line would not be part of the solutions. Okay, I've got one last line to do. I'm going to switch to red. This says y is less than or equal to, or no, sorry, y is greater than -3. So this is going to be a line where all the y coordinates are -3. So I've got 0, -3. -2, -3, -4, -3, -6, -3, 3, -3, 8, -3. And if I graph all those points, you can see it's making a horizontal line. So now I'm looking at the symbol. Greater than means dotted line. So I'm going to go ahead and make this dotted. And I'll choose a point to plug in. For this one, I'm going to go ahead and use the point 2, 1. Okay, 2 for x, 1 for y. And for this inequality, I only have a y coordinate to plug in. I can't plug in the x coordinate because there's no x there. So I've got y is greater than -3. Is it true that 1 is bigger than a negative? Yes, that is true. So this point is true. That means everything on the other side of the red line is false. And so for the red line, I'm going to shade this way from the red line. And so all of my answers for this problem are where the blue, the red, and the pencil are at the same time. So right in here, this is where all my answers are. And then I cannot use anything on this dotted line. I cannot use anything on this dotted line, but the answers on this solid line are okay. Not down here, because they're not part of the triple shaded area, but I can use them right here because they're right on the edge of that triple shaded area. So all these answers are good, and then right here. So what I mean by answers, I mean if you picked a point in this area, you could pick any point in this area and plug it into all 3 of these and it would make them true. If I were to pick a point over here, I could only plug it into the pencil and the blue and it would be true. If I plugged it into red, it would be false. If I picked an answer over here, I could plug it into pencil and red and it would be true, but if I plugged it into blue, it would be false. So if I pick a point, an x and a y coordinate right here in this middle part, I could plug it into all 3 and it would be true for all 3 of them. So we call it a solution.